Hello everybody, so today I want to talk about calculus. The topic today is about Cauchy Residue Theorem. So now I want to show you how to answer. About z, we know that this is about the complex numbers. So we have z equals to a plus bi. So we have the absolute value of z. That means they will be like this. And this one equals to number 1. Now we put the power 2 for the both sides. So we have a square plus b square equals to 1 square. So if we look carefully about this one, we can apply the formula of the circle. So we have a minus c to the power of 2 plus b minus d to the power of 2 equals to r square. So the center that should be about CD, and the radius that is about r. So if we look carefully about this one, the center that is about 0, 0, because C and D they don't have in here. That means they are equals to number 0. The radius is about number 1. Now we need to write about the circle in here. So A for the real number, B for imaginary numbers. So in this one, we have this equation. So we need to find the poles of integral. So to do this one, we need to concentrate on this one in here, the denominator. So I will put about z minus 1 equals to number 0 and z minus I equals to number 0. So I will put this one go to the right. And now we have z equals to number 1 and z equals to positive I. So we know that z equals to this one. And now we need to transform z into a plus bi equals to number 1 and a plus bi equals to I. So number 1, that is about 1 plus 0 I. And the second one, this one, that is about 0 plus 1 I. And now after we follow this way, we can see that A equals to number 1, B equals to number 0. And the second one, so we have A equals to number 0, B equals to number 1. So now we find location 1, 0 and 0, 1. For the first one, A equals to number 1, that's it in here. And the second one, that should be in here. So we can see that 2 locations on the circle. So we just find the poles in here because they belong to this region of the circle in here. Now let's go to the poles. Z equals to number 1. So we have g of z equals to f of z. F of z, that is about this one in here, multiplied by z minus number 1. So if we have this one multiplied by this one, we cancel z minus number 1 in here. And now we can find about the residue of f of number 1, or we can equal to g of number 1. So we put number 1 cone here, and we have like this. Now let's go to the second one. So for this one, we do the same. But now we multiply by z minus I. So if we simplify, we have e to the power of b over 2. And we have z minus number 1. And now we can find about residue f of I, or we will go about g of I, and we have like this. And now after we have everything, we can get the final answer in here. So that should be about 2bi, and we need to sum about 2 residues in here. This one and this one. So I will put this one go like this. So we put the value cone here. So this one, that is about this one, and this one, that is about this one. So we see that I minus number 1, we can change into negative, and we have e to the power of b over 2 over 1 minus I. And they cancel, and we have number 0 in here. This is the end. Thank you for watching.